Hey everyone.
Hello.
Hello.
Hi.
All right, we are Eggman Robotics, and welcome to our second information session for EGgBOAT.
Woo.
We're gonna go around and
I'm
introduce
Alec.
the team.
I'm Alex Schrader. I'm doing electrical lead for the navigation system.
I am Justin. I am the draftsman.
Oh, it's my. I'm Jacob. I've been working on CAD modeling with Justin and been helping test EGgBOAT in person with Embry.
Hi, my name is Brendan. I'm a sophomore here at Embry-Riddle, and I've been helping out with some of the testing and some of the final touch manufacturing and kind of some of the reports and the TEDP we most recently did. So,
Hi, I'm Brian. I'm electrical engineering, but I've been helping out a lot with manufacturing and testing.
Yeah, and so just recently we submitted a TEDP to NASA. That would be the Technical Evaluation Data Package, and we wanted to
Test data.
test equipment to test data.
See, we just make up anagrams or acronyms.
Acronyms.
That's right.
We just throw them around.
But we had to do a lot of work recently to get EGgBOAT ready for that, so we wanted to share some of that with you.
Yeah, it's really exciting. So we hope you enjoy this footage.
Yeah. So
We worked very hard.
part of
Please like it.
filling in that data package was submitting a video called the Proof of Concept video, and NASA wanted to see basically the same document that we wrote up for them in video format, so we had to submit that to NASA recently. But before we go over that, we had to make a report, and so our report was made over the course of 24 hours. We were running a little late on gathering footage for the video, so that was kind of put on the back burner a little farther than we wanted. But here are some screenshots from that. We've got a couple sections here. The square wave conversion tactics that Alex is working on were discussed, as well as some other mechanical features like the new control bay with the computer module in it known as an Arduino that's used to control EGgBOAT as soon as that's in operation. So those are just some samples of what we were writing up there. You'll see on screen. And so now, past that, once that was completed, we had to create and film a video that was submitted with that. A video that would go over all of EGgBOAT up to date, as well as changes that we made since the original proposal. Yeah. Any comments on making the video? These two were here in person.
It got rained out so many
The
times.
first time we were rained out of the pool, which shouldn't be an issue until you consider lightning and the fact that Florida is the lightning capital of the U.S. and the fact that you can't be in the pool when there's lightning. So we had to cancel filming day one and come back the next week and pick up filming again, which thankfully we did get really good footage, and we got to drag. Brian got to ride EGgBOAT.
Got to ride EGgBOAT.
Yeah.
Yeah. Yeah,
There's only one man in the world who can say he's ever ridden an EGgBOAT, and that's this guy right here.
Yeah.
Now, the other thing that the rain actually did hold back was our Arduino testing. So what you'll see is that it is partially autonomous in terms that we had a pre-programmed path and attempted to run that course.
Yeah, so recall that EGgBOAT is an autonomous transport vessel that will use radio antennas to navigate towards NASA's Angel Beacon that every astronaut wears in case of an emergency upon splashdown. And so that navigation system is still being perfected by Alex up at Georgia Tech. Once that's done, they'll come together, but for now, we're just using the controller and proving that the controller can move EGgBOAT on its own without a human controlling it. If you remember from the previous info session and those videos, which will be recapped at the end of this stream, EGgBOAT got controlled by an RC remote, which, while that's useful to show that the vessel's working, doesn't really prove that it's autonomous. So now that we've got the computer controlling it, we can say at least it was hands-on. The navigation system is still to be added to that, but it was a good success.
So all the footage you see of EGgBOAT in this most recent video is just of EGgBOAT navigating solely on its own without human interaction as soon as we release it. So, which is pretty cool. So it's now proving its truly autonomous nature. So it's earned the A for now in its acronym.
That's right. Alright, and so we want to show you that video, so we're going to put that up on screen now. It took a full 24 hours to make, which is quite some time. So we hope you enjoy.
Hello, and welcome to our proof of concept demonstration. We were tasked with the Microgravity Challenge 2, the SAVER Challenge.
SAVER stands for Surface Autonomous Vehicle for Emergency Response. Our proposed solution is the Electronically Guided, Buoyant Optimized Autonomous Transport, or EGgBOAT for short.
We'll begin our demonstration by going over our sidewall configurations, battery box placement and configurations, power and control bays, and our main hull storage space.
Following this is our physical demonstration of the EGgBOAT with a pre-programmed Arduino path, a torque test, and a speed test.
To end it out, we will go over our antenna array and demonstrate its receiving capabilities.
The main concept of EGgBOAT is that we wanted to capture a lightweight vessel made entirely from 3D printed structures. We achieved this by printing all 3 hulls out of PETG and their respective caps, as well as the antenna stand with PLA.
The hull's caps were sanded, bondoed, billet primed, base coated with orange paint, and then finally coated with the gold paint to create a smooth and strong surface with the same color as the original plastic.
Our side hulls each contain a single ESC, brushless motor, and LiPo battery within its own waterproof battery box. The subsystems of EGgBOAT include the control pod, power pod, 2 motor assemblies, and the antenna array. The 2 LiPos share power in parallel to all of the subsystems.
The main hull carries the required 2-liter platypus water bag. It also contains all the pass-through wiring, which will be tucked away in the final design. The hull also boasts a latching lid and supports the antenna stand. The lid itself is spring tensioned, so it is able to reset itself with no external influence and can be pressed back into place on the boat rather than having to turn the handle. The power pod contains our servo-actuated kill switch and power distribution board. The PDB supplies power to all the subsystems, and the kill switch cuts all power from the system.
The control pod includes our receiver for the kill switch and the Arduino unit. The receiver receives a 2.4 GHz signal from a remote controller, handled by a team member in case a mission abort call is given. The Arduino takes in the antenna array's signals and processes them to give specific motor control functions to locate and travel to the Angel beacon.
The antenna platform, being elevated above the vessel, carries the 3 antenna structures and its signal manipulation boards locally within the antenna stand.
To help with water resistance, EGgBOAT has been coated in Gorilla waterproof patch and seal, which keeps the hulls watertight and dry. We first tested the device in a local bathtub to test its water resistance, and eventually found a local pool to test in. EGgBOAT at full throttle has a recorded speed of up to 3 miles per hour and a pulling force of up to 3 pounds of torque. Our design also allows the vessel to be quite maneuverable when turning, using the available differential thrust.
Along with water tests, we performed a hardware safety test on the kill switch. During testing, we found that it activates within 317 milliseconds, which is under the required 500 milliseconds.
The development of the navigation hardware started with the antennas. Normal mode helical antennas were chosen as the antenna type for their omnidirectional radiation pattern and highly adjustable effective length. 3D printed wire mounts were created for repeatable construction of the antennas. The antenna output then needed to be filtered to remove background noise. A third-order bandpass filter was designed to accomplish this. Unless the transmitter is right beside the receiving antenna, the signal is too weak to use, so an RF amplifier circuit was designed to amplify it. After filtering out the amplified noise, the output at a transmitter distance of 20 meters was a clean 170 millivolt peak-to-peak sine wave. In order to use this wave in high-speed digital logic, it needed to be converted to a digital square wave. This was successfully accomplished by designing a circuit incorporating an RF comparator with adjustable hysteresis in order to account for any remaining noise. Next, each of these square waves is used in the phase comparison circuitry. This is the step we're currently on. Using low-speed 7400s and 7474s on a 5-volt power rail, we're able to verify that the circuit topology works as intended, with 1 degree of phase difference corresponding to about 10 millivolt difference in output. We're currently implementing the circuit using the high-speed SMD equivalents to these components. Once it has been manufactured and tested, all of the aforementioned circuits will be combined into a single PCB, taking as input the 3 antenna signals and outputting the phase comparison voltage.
Some future design changes for EGgBOAT may include purge pumps that dispose of any water still getting into the hull regions, or in the case of the side hulls, act as a water cooling system for the motor, while still keeping the hulls dry, and the recoating of the main hull. Other issues may present themselves yet when we are finally able to merge the vessel and navigation systems. However, with our experience and perseverance, these problems will be overcome.
And we're back. We're back.
Welcome back.
Alright, so that was,
Wow.
again, our proof of concept video submitted to NASA earlier this week. Or end of last week, middle of last week. Yeah, something like that. Last Tuesday. And that was requested to be listed as private on YouTube, so we want to share that with you now since that hasn't gone out yet. We really like the visuals in it. It's quite informational, yet nothing too crazy. It's a good balance of cinematography and all of this. So, yeah,
Indeed it was.
I think Brian had fun in the pool getting pulled around.
It was fun being able to not do anything and still swim.
You just held on to EGgBOAT and had it drag you through.
We do have that footage of him being pulled around, but elected not to put it in the proof of concept video.
Because that was not part of what we were actually testing.
That's right.
That was a side note.
Yeah, so just for some quick stats, up to this point, all of the testing that we've done on EGgBOAT has been performed on the same batteries. We've projected at least 2 hours of full speed runtime on the batteries, but it's most likely more. So that's very good. The LiPo batteries are doing better than expected. And in the test, it made a top speed of 3 miles per hour, which is just a whopping neck-breaking speed. I mean, you got people
It's
like,
faster than we can walk.
it's crazy. And pulled a total of 3 pounds, so we're sticking with the 3 unit. It was like 2.9 something was the weight force getting pulled on that. So that was all concluded in our report that we wrote up to NASA. All right, and I guess now that leads us into our next section. If you guys have questions at any time during the stream, please do not hesitate to ask them in chat. That would be we'd love to hear from you, so that'd be great. All right, so we're gonna the bar on the bottom is gonna do the magic thing. Did the magic thing. All right, and now you'll find us on the EGgBOAT update section. So, as shown in the proof of concept video, we want to brief you on the changes that have been made. So, Alex is gonna lead us first into a navigational update as to what's going on up at Georgia Tech and what he's been working on.
All right, thanks, Jacob. So since the last info session, there's been a ton that has gotten done. I think at that point, if I remember correctly, we had prototypes working for the antennas, although they weren't, very replicable, and they weren't very sturdy. Then we had the initial filters to take the input signal from the antennas and try to remove the noise. Since then, almost everything else has been created. We're in the final stages trying to get one more circuit board working and then combining them all. So right now, the antennas, they've been updated with help from 3D modeling from Jacob. We've made them very replicable. We had a winding structure before where you'd wind the wire around, but now we have a way to have it end at the exact same point each time. You stick it in a little hole here, and then a way to secure the female SMA connector at the bottom. So now we've got so far 3 almost completely identical antennas, which will perform really well. And then we've got a bunch of extras that we'll have for backups. This signal that it receives goes through that 121.65 megahertz bandpass filter, which is pretty much the same as we had from last update. But then from there is where all the new work's gone. This signal at a couple meters away is really very weak. It's only a couple of tens of millivolt peak to peak. So we need to amplify that. We need to make that a lot stronger because you can't really do anything with a signal that's so small. That's, it's not much more than just background noise um, on circuit boards. So we take that and we put it through a RF amplifier, which amplifies that couple millivolts peak to peak to a couple hundred millivolts peak to peak. This took a while to get it working, and we had some problems with it inserting a lot of extra noise. But eventually, we got it working, and we have a working circuit board for it. Then the output of this is 121.65 millivolts sine wave. We found that at I believe it was about 20 meters, we got about 170 millivolt peak to peak, which is more than enough than we need. So that's really great sign because I don't know how far it's going to be operating, but theoretically, we could operate it a lot further. Just back of the hand calculation, based on the other components, which I'm about to mention, we could probably have that, still being read from at least 1 to 200 meters out, based on, what the threshold voltage that we need is. Anyway, once the RF amplifier takes the signal and makes it larger, we do a little bit more filtering, which has been tested and works. And the output of all this is a pretty clean, at least at 20 meters, 170 millivolt peak to peak signal. What happens to this? In order to do any of the digital comparison that we need, which is pretty necessary because otherwise, if we are trying to do any sort of analog phase comparison, all the amplitudes are going to be completely different. The waveform isn't going to be perfect. So in order to have it in some predictable way, we want it to turn to a digital signal, which would just be any sort of sine wave would go to a square wave, and then we can use widely available logic chips to manipulate it in any sort of way that we want. And the way that we take this sine wave signal and output a 0 to power square wave is with a chip called a comparator. At the speeds that we're switching, they get pretty expensive, like about $4, which is not a ton of money, but for very tiny electronic components is quite a bit. I probably fit 10 to 20 of them on the size of like my pinky nail. Like they're incredibly small chips. But taking this, we were able to build a board and also have this completely successfully working. Right now, since we don't have the beacon and we're still figuring out, or at least finalizing a way that we're going to get a transmitter working, just using a signal generator to input the signal that we'll get from the antenna after amplification and filtering, feeding that into the comparator and getting a really nice, smooth output from it of a square wave, which is perfect because that's exactly what we need for the high-speed electronics. So in total, everything I've covered so far, antenna will take the signal, manipulate it, and eventually output a square wave. So we'll have that circuit with all the manipulation for every single antenna, and those will feed into the high-speed digital circuit, which is the phase comparison. This is currently what's in the works. Right now, none of us, or at least I haven't, I'm leading this, I haven't done any work with high-speed digital logic. Anything above around like 40 megahertz you have to know all these like completely different design principles because nothing behaves ideally anymore. So right now I'm trying to learn as much as I can about that so that we can design it effectively, because a prototype design without knowing that wasn't working past a couple of megahertz. So we're going to try to figure that out. It'll take a little bit of time, but should get it done. And then the output of that just does a little bit of filtering and signal manipulation, which has already been finished, and that will be read from the microcontroller. So right now, the only big thing left is trying to get the phase comparison digital circuitry working, and then combining it all into one circuit and making sure that still works. Because on this, this high frequency, even the shape or the placement of components on a circuit board can have significant effects on the waveform. Yeah, that's where we are right now. And then after all that's done and the board's working, we'll do some testing, and then most of it's just going to be programming from there. But we could do programming anywhere and as up to the day of testing if we need to. So that's the update for navigation.
Yep. And so we will have the extent of working on this, at least in lab form, until May 6th-ish, I believe is when Alex is planning on traveling home from college. So, and he'll bring his stuff with him. I travel back near to that same date, maybe a couple of days before, and EGgBOAT's actually going to travel back with me. We were originally planning on shipping it out from here at Embry-Riddle, but we kind of acknowledged the fact that if it were to be taken with one of the students, it could be worked on for at least another 10 days, 9 days, at least a week. So, and that could be very valuable time to finish up some parts. So that's pretty important. So we're going to go that route. But on the hardware side of things, or at least on the vessel hardware side of things, we've started to work on some new pieces. Yeah.
So as you can see, as you probably saw from the from the demonstration video, we have these new battery boxes. They contain and withhold our LiPo batteries, and displays the milliamps and voltages of each of the battery. Each hull will get one. This was requested upon from NASA themselves, or the micro-G team at NASA, that we have to store our batteries within a waterproof container. This is our solution to that. We're basically doing the exact same thing as our watertight hulls by having a 3D printed shell and then just coating it.
That's right, and on the bottom of each of these is a magnetic tray system. You can see on the bottom there will be a couple magnetic dots on the corners, and those actually just snap into a mount on the in the EGgBOAT hull. So it's very easy to kind of just plug that in and just kind of click it in. So that's been convenient, and we were able to test that for the proof of concept video, and that worked well.
It did work very well.
We're waiting on one more lid for one of those, but past that, that's the only thing that needs to be 3D printed. If I remember right, the last info session we did not have the hatch ready. Is that true?
I don't believe we did. I think we had half of it ready.
Yeah. So
But
this is
now-
the new hull latching system that we're working on. If you recall from the original design, the main hatch was screwed in, which isn't very convenient if you're trying to reach a astronaut in an emergency situation. Most astronauts in emergency situations out in the water after splashdown aren't going to be carrying around screwdrivers with them ready to crack open this vessel. So we wanted to make sure that they would have quick and easy access into that central hull where the payload is kept, which is typically a 2-liter water bag. So we used a spring latching system that consists of a couple of 3D printed parts and latches that slide in and out using that 60-degree turning handle. And so we started working on that and finished that about, I don't know how many, it was a couple weeks ago, and we've been fine-tuning that system. And so after that, we started working on the antenna platform. That has been made in the proof of concept video. You'll see, or if you recall seeing, there was a new antenna platform on EGgBOAT, very different from the original size. It's a lot bigger, stretches out to the full bounds of size that we were given by NASA. That way we can get the antennas as far away apart as possible. Alex was kind of requesting that. It's the wavelength of that is 1 meter between each full period length. Alex might be better off at explaining that thing.
Yeah. So any sort of electromagnetic signal, traveling through the air, is going to travel at approximately the speed of light. At 121 megahertz, that's going to mean it's going to have a wavelength of about, I think it's about 2.5 meters. So in order to accurately measure, we want about at least half of that. That's still even too big for this though, so we're trying to get as close as possible. So I'll let Jacob take away the rest.
That's right. So we wanted to maximize the distance between the triangulation points without breaking an equilateral triangle, and that was just to go from front to back on the biggest size possible on it. So I think that left us with about I think it's 20-something inches length between the antennas, which was pretty good for what we originally had compared to our original 7-inch, I think, difference between antennas. So we've increased that largely. The other major changes were the installation of a power system. There's now a power distribution board. That includes a couple of regulators, a 5-volt regulator and 12-volt regulator to supply power to auxiliary systems. And we finally ran the cables now that each battery, when they're plugged in, are shared power in parallel to both motors. That way, if you're turning, one motor doesn't take more power from the battery than the other side. They'll both run out at the same time together, so that's kind of convenient not to have one side die on you while the other side's not. So, better equal power sharing. And then those power have now been routed to the new control board that Brian worked on programming, and he did good with that. Figured he might be able to add to that.
Currently for now we're using an Arduino Uno to control our motors. We worked on just really basic code for about, I don't know, a week to try and figure it out. Found out you have to use a very specific servo library that moves on a degree basis of 180 degree turn for basic servo control, and since the ESCs read a very specific waveform, so gotta run that like 2 days before a test day.
Yeah, so that was a last-minute addition to the list of things we wanted in proof of concept. It wasn't required to show a fully autonomous vessel in the sense that we weren't controlling it, but we decided that it would be best if we showed at least Arduino capability. So we wanted to throw that in there, show a proof of concept, if you will, as the title suggests. So, Brian did good working on that and got that done before the proof of concept video was filmed, and then even was able to adjust the pre-programmed code at the pool while we were testing it. So he would be in and out of the water typing up some fresh code for that, so that was pretty interesting to watch. But the only other thing we've worked on for EGgBOAT as far as the hull was 2 surface finish projects. The first one, the external hulls, each side hull needed recoated. The Flex Seal started peeling up on that. If you recall from our original videos, we did some flow tests and had some issues in the bathtub where it was leaking, and so we coated it in Flex Seal. Well, that stuff started peeling up, and we're not really sure about the integrity of that, whether that was us not sanding the surface properly, giving it a texture to adhere to, or what. But we decided to peel that up, add a new Gorilla Glue spray, and that's gone on really well so far. So we're happy with that product. And aside from that, we've started working on different surface finishing for the upper hulls. We wanted to kind of give it an injection molded plastic look, more than the 3D printed parts, and we decided to do a little bit of Bondo layering and use what's called Rust-Oleum 2-in-1 sandable filler. And that stuff, once you put it on, you kind of sand it down and you sand down the Bondo, and it fills cracks and layers, and you're able to spray paint over that afterwards for a really smooth look on EGgBOAT.
You think the GoPro could actually pick up the different textures since we have 2 different holes?
I think that might be able to show. So Brian's going to move around the GoPro here and be able to show the difference between the 2 textures, or at least maybe show the white parts at least. Yeah.
So see if the camera can actually pick up anything. So
if you'll see on this part, I just try to get the lighting right here for this to show. There it is. In the middle of the part there's a lot of layer lines. You'll see at the peak of the part right about here. You'll see a lot of layer lines. There's nothing wrong with that. You see some of the layer lines on the back. Stuff's a little different. There's nothing wrong with that, but it kind of shows how much it is 3D printed, and there's a little bit of stigma surrounding the weakness of 3D prints in the real world industry. So we kind of wanted to give it the injection molded plastic look. And so here we have the actual hash to compare to those. And
so one thing that you will really notice is, like, that's pretty smooth, well-rounded, but if you notice back on the side lid, we have this giant lip here. This manhole was put together the exact same way, and you can't really see that bump anymore. You can see where it's roughly positioned, but you can't see it in its full form.
Yeah, so it makes it look a lot more pretty and a lot more egg-like.
that's right. Yeah.
Which is what we're going for.
We ended up doing that hatch part first, and that was kind of our trial run. I had never done the Bondo part finishing before that, so that was kind of new territory. And then we ended up doing all of the side holes Brian can kind of point to the front of the main hall that's on screen here. That's really smooth as well. That part up front has all been finished. Every gold surface on the halls was done. We still have a couple more parts to do,
Nice
but
and smooth now.
yeah, that's been going well. So we after that, we finished that right before the proof of concept video. We painted that and got featured in the video. So we were happy with how that looks. All the other parts will be finished like that, and we'll have a very smooth looking egg boat by the time we go down there. So I think they'll be pretty impressed by most of the fact that they kind of expect that we have this 3D printed product, and we have kept them updated on the surface finishing part. But until you see it in person, you kind of realize, oh wow, that is really smooth. So looks good. But aside from those physical updates, we have a big news update, point of interest news update for you all. As you can see on our timeline below us in the stream,
What's the question mark mean?
There are 3 question marks.
Oh, 3?
There's
Yeah,
three.
there are 3.
Yeah,
It's
there's
gotta be
3 of
big
man.
news then, right?
quite an interesting thing here. What if we just? Oh, it's time.
Is it?
We have a very special set of news to release to you guys today. All right, are we ready for such a thing? This is big news media drop here from the Eggman Robotics team. All right, we're gonna pull this up. Oh yeah, this is it. What could this possibly be? All right, Brian, you ready to take us through this?
Oh man. Okay, so introducing the chicken coop. Hold on, are you?
I'm on. Are you ready for next slide?
Yeah.
Oh wait, here, you do because you know when you're on.
Okay.
All right.
So we got the chicken coop, where we now have our own line of clothing and some freshly served memes. So we got some really snazzy designs over on a spread shop. This is where you can support us, or this is more another way that you can support us but still get something back out of it. This has been in the works for, I don't know, 2.5 months now.
Way too long. Yeah.
And it's not just clothes. We got a teddy bear.
There's a lot going on in this merch store. There's
Oh,
lots of goodies and things to find like that. So yeah, we're very excited to release this. As Brian said, it's a great way to help fundraise for the team. We make a certain amount of profit based off of sales of this store. Since they're our designs, we don't manage the shipping or production of them, but since we provide them with our designs, they're allowed to send us a profit margin from us. So yeah, if you guys would consider buying merch, we would greatly appreciate it. We're going to post that on our Instagram, Facebook,
Everywhere.
everywhere you
It's
find
gonna
us, it will exist. So yeah, we'll be dropping that link very soon. See a lot of people happy about the merch. Yeah, we've been wanting to get that out as soon as possible. I think I've been super excited ever since I
Yes.
started working on designs. I've been like, I wanna buy this, and I'm like, okay, but it's not ready. I'm like, so we're very happy that's out. But
We've had a lot of people just here when we're working on designs. They're like, "Hey, when is that gonna come out?" So it's some exciting stuff.
that's right. The time is now. Yeah. If you we know you guys just got your paychecks, last week. Just absolutely splurge all of that on EGgBOAT merch. It looks awesome. You're gonna look rad. Everybody's gonna be like, "What is an EGgBOAT?" And you're gonna have this whole moment where you might not really know, but you'll at least sound way cooler than them. So,
Oh, yeah.
yeah, that's right.
Especially if you get the one with the anagram on the back.
That's right. You could be like, "Yo, you can just check out the back of it, and you won't even have to remember it, but they'll think you know." It's top tier marketing, and we're very happy with the store. Happy to release it to you guys. So you'll find that link on a couple different websites, Instagram and Facebook for sure.
It's gonna be on our link tree, so
That's right.
even on YouTube it'll be up there if you go to our channel description. I believe it's under there.
Yeah.
It might actually just be under the video description.
That's
I'll
right.
have to go add it to the channel.
Yeah, we'll make sure we post around as many places as possible for you guys to access. We're definitely excited. Justin already got some merch today, so lots of people feeding into this. So it's a great way to support the team and get some cool swag for yourself while you're doing it. So. All right. With that, we're gonna open the floor up to questions for like 2 minutes here. I'm gonna wait to see if they pop in the chat. I know stream's lagging behind, so we're gonna give like 5 minutes. Maybe answer a couple questions if there are, and then we're gonna re-show the videos at the end, and stream will end after this. So there's about 10 minutes of footage. We're gonna show the proof of concept video, and then see some other things from the first info session, like a couple videos of us testing. Any amount of footage to bring to you guys we want to show you.
Yes, sir.
Again, if you do have any questions, please feel free to drop those in chat. We'd love to hear from you. All that's left on the list is to complete some poster boards that will be showcased at the JSC once we work with those. And it'll be like a trifold poster display.
You know, like science fair.
Yeah,
just like it'll fold out. It'll be incredible.
It'll be whack.
Yeah.
Out of the waz.
Absolutely crazy. And so we're going to be sending that over to NASA for them to print for us for use at Houston when some engineers and different NASA employees come around to talk for us. So hoping the EGgBOAT will be done and ready by then. By all means possible, we will get this done. So that's right. No matter what, we make the best out of the situation we've given. We put our best foot forward and put EGgBOAT first. That's right.
Well, school first.
Yeah, we're students first, but
and then EGgBOAT.
EGgBOAT is
comes on that list.
Quite the project due for some admirations.
Any questions?
I don't think we have any questions, so we're not
We've
gonna.
only sat for 2 minutes.
Did the stream catch up? Did we get there? Can't really tell. Trying to give enough time to answer questions. Yeah, we did only sit 2 minutes. We're gonna try to sit till around 7 and then play the videos.
Yeah. So if you have any questions, just drop them in the chat so we can answer them during these last couple minutes. Even if you don't have a question, just make up a question.
That's right.
So we can answer.
Does it fly?
Good
We
job.
don't know.
We don't know yet.
Someone asked earlier.
If
Someone
you have
asked
a
how
lot
much
of
can
tall buildings-
EGgBOAT
Have
pull.
we thrown it yet?
How much can it pull?
No.
Yeah, someone asked how much can it pull.
Someone
Well, we
did
know
ask
that.
how much can it pull. It can pull. So it can pull a lot of weight, but the way we measure that is a little bit different since it goes in the water. The two thrusters are each going to push out together, equitable to 3 pounds
About
of
3
force.
pounds force from that.
Which when you're in the
But-
water, yeah. When you're in the water, it can pull a lot more. Like it's been pushing around different people in the pool, can move a lot of weight. So it's like
During
It's a-
testing, I weighed 270, and it was pulling me like nothing. So
yeah. So since it's a aquatic vessel and it's got to pull stuff in the water, stuff is kind of in a fluid. It's not like pulling a dead weight, so it can pull a lot of force, but pushes water out at 3 pounds of force with both motors. Alright, we at least caught up to the grades section. The chat has gotten involved over the grades conflict. I've thrown myself under the bus by saying that EGgBOAT's first, despite us being students.
How could you?
I know.
Come
I've
on.
abandoned all hope. I'm hopeless.
Gosh dang it.
I'm gonna have
I mean,
to
we
drop
only
the
got 1
project.
week.
Yeah, that's it.
We decided not to take our finals and just work on EGgBOAT instead.
Yeah.
Direct correlation with NASA. Who needs
Yeah.
school anymore?
Yeah, absolutely. Great idea.
Make it to Houston and see if we can just hide in the building somewhere. Maybe they'll be like, "Yo, that looks like an intern."
I mean, we'll have a badge and everything.
Yeah, then our badge will say expired on it, and then they'll start chasing us around the compound.
We'll be about as official as college kids get at a NASA center. So that's
Then we'll just try not to laugh when we start saying we're Eggman Robotics.
yeah. They said in our original feedback for the design that they said the detail or something about it offset the novelty of the design. So despite us being a little quirky, we definitely put in some good work, and NASA seems to think so too. So.
Will it survive?
anyone saw the most recent Starship launch, SpaceX is doing great things down in Boca Chica, Texas. They just launched man's most powerful vehicle ever made, and in doing so, destroyed a mile radius circle that anything in it was destroyed. There was a Dodge Caravan minivan parked three quarters of a mile out, and that thing got what we like to call obliterated by rock and debris from the launch. They didn't have a lot of launch control systems like NASA has down at Cape Canaveral. There are other sites where they use water to suppress some of the blast, and they didn't have any of that set up, and they kind of blew a hole in the earth. So, yeah,
it happens.
Man's most powerful vehicle was pretty powerful. Who would have known?
Who would have thought?
Who would have known? But
It became a good mining tool.
will it survive concrete strikes from the launch pad? If we had to run that in a probability from 0 feet away from the rocket to a mile away from the rocket, that'd probably vary somewhere from negative 20% chance of survival to, I don't know, maybe 80% chance. Somewhere, yeah.
And I mean, it's also technically not supposed to be on land, but if it was on land when the rocket went off, there's a high chance it's not going to live. But if it's in the water, I mean, technically there's a chance for it. I mean, the water.
Just have it run, you know.
Have it programmed to run away when the rocket launches.
All right, I think with that will be our only and last question. Quite the amount of questions here. We are planning on doing another info session at some point. Hopefully, at least recapping. Definitely, we will be recapping our trip for you guys once we go down to Houston, but that's a little later. So once we submit EGgBOAT, we might do another quick info session to talk about what got done in those last couple of weeks here coming up and what happened with shipping it out. So we definitely like to keep you updated, so we want to bring you that information. But for now, thank you guys for all watching.
Yeah, thank you.
We appreciate you all as viewers, and we hope you guys catch us in the next one. For now, though, sit tight. We're going to replay those videos for everybody watching. Enjoy. Thank you.
Bye.
See you later. Thank you for watching.
Bye.
Hello, and welcome to our proof of concept demonstration. We were tasked with the Microgravity Challenge 2, the SAVER Challenge.
SAVER stands for Surface Autonomous Vehicle for Emergency Response. Our proposed solution is the Electronically Guided, Buoyant Optimized Autonomous Transport, or EGgBOAT for short.
We'll begin our demonstration by going over our sidewall configurations, battery box placement and configurations, power and control bays, and our main hull storage space.
Following this is our physical demonstration of the EGgBOAT with a pre-programmed Arduino path, a torque test, and a speed test.
To end it out, we will go over our antenna array and demonstrate its receiving capabilities.
The main concept of EGgBOAT is that we wanted to capture a lightweight vessel made entirely from 3D printed structures. We achieved this by printing all 3 holes out of PETG and their respective caps, as well as the antenna stand with PLA.
The hull's caps were sanded, bondoed, billet primed, base coated with orange paint, and then finally coated with the gold paint to create a smooth and strong surface with the same color as the original plastic.
Our side hulls each contain a single ESC, brushless motor, and LiPo battery within its own waterproof battery box. The subsystems of EGgBOAT include the control pod, power pod, 2 motor assemblies, and the antenna array. The 2 LiPos share power in parallel to all of the subsystems.
The main hull carries the required 2-liter platypus water bag. It also contains all the pass-through wiring, which will be tucked away in the final design. The hull also boasts a latching lid and supports the antenna stand. The lid itself is spring tensioned, so it is able to reset itself with no external influence and can be pressed back into place on the boat rather than having to turn the handle. The power pod contains our servo-actuated kill switch and power distribution board. The PDB supplies power to all the subsystems, and the kill switch cuts all power from the system.
The control pod includes our receiver for the kill switch and the Arduino unit. The receiver receives a 2.4 GHz signal from a remote controller, handled by a team member in case a mission abort call is given. The Arduino takes in the antenna array's signals and processes them to give specific motor control functions to locate and travel to the Angel beacon.
The antenna platform, being elevated above the vessel, carries the 3 antenna structures and its signal manipulation boards locally within the antenna stand.
To help with water resistance, EGgBOAT has been coated in Gorilla Waterproof Patch and Seal, which keeps the holes watertight and dry. We first tested the device in a local bathtub to test its water resistance, and eventually found a local pool to test in. EGgBOAT at full throttle has a recorded speed of up to 3 miles per hour and a pulling force of up to 3 pounds of torque. Our design also allows the vessel to be quite maneuverable when turning, using the available differential thrust.
Along with water tests, we performed a hardware safety test on the kill switch. During testing, we found that it activates within 317 milliseconds, which is under the required 500 milliseconds.
The development of the navigation hardware started with the antennas. Normal mode helical antennas were chosen as the antenna type for their omnidirectional radiation pattern and highly adjustable effective length. 3D printed wire mounts were created for repeatable construction of the antennas. The antenna output then needed to be filtered to remove background noise. A third-order bandpass filter was designed to accomplish this. Unless the transmitter is right beside the receiving antenna, the signal is too weak to use, so an RF amplifier circuit was designed to amplify it. After filtering out the amplified noise, the output at a transmitter distance of 20 meters was a clean 170 millivolt peak-to-peak sine wave. In order to use this wave in high-speed digital logic, it needed to be converted to a digital square wave. This was successfully accomplished by designing a circuit incorporating an RF comparator with adjustable hysteresis in order to account for any remaining noise. Next, each of these square waves is used in the phase comparison circuitry. This is the step we're currently on. Using low-speed 7400s and 7474s on a 5-volt power rail, we're able to verify that the circuit topology works as intended, with 1 degree of phase difference corresponding to about 10 millivolt difference in output. We're currently implementing the circuit using the high-speed SMD equivalents to these components. Once it has been manufactured and tested, all of the aforementioned circuits will be combined into a single PCB, taking as input the 3 antenna signals and outputting the phase comparison voltage.
Some future design changes for EGgBOAT may include purge pumps that dispose of any water still getting into the hull regions, or in the case of the side hulls, act as a water cooling system for the motor, while still keeping the hulls dry, and the recoating of the main hull. Other issues may present themselves yet when we are finally able to merge the vessel and navigation systems. However, with our experience and perseverance, these problems will be overcome.
Brian, you're on catch.
Nice. Well, we know it moves. How fast can you spin in a circle? It does tricks. What?
Wait, quickly, this is the most fast floating space simple.
Oh, yes, it is.
You gotta get that color in it. Oh, that 360 can't go be sick.
Yeah, it is. I can stabilize it. Wait, that is equal for all the loading.
There you go. Okay, well, the R6 system. Actually, Brendan, you want to go check it for a second? That it is.
Hey, Brian's in the pool for it.
All you, man.
Now we direct you straight down. Watch out, Brian. He's gonna run you over. Here you go. Brendan.
Yeah, what if you try holding in one spot?
That's half throttle.
Pushing Brian. Hang on, at least this isn't full yet. That's 3/4. Don't go for rock test. It's pretty stable. Nice. What was that?
Haley is what that was.
Hold tight. No, he's another one that we worked at. Yeah, and then I mentioned the possibility of long time resisting that, he was saying that this happens with other surgeries, and basically I somehow spread the virus to my eye, like try and like put some nose down my eye or whatever. And that's why this guy turned it over. And do it with the bag too. Yeah. Go back. So I just basically cleaned up. You can try and go side too.
Side to side.
Later this afternoon, I'll probably go by a couple of days and get back.
Find the back pipe.
What I can tell, you know. When you look underneath, do you see the water going back out forward of the same insert?
It's going backwards?
When we go backwards.
It should. Oh yeah.
Yep. That's good news.
Using it as
That's
a
what he turns
preserver.
around once I get there.
How would that work?
Like I mean, it could be battery. Like we just used all the battery on one side, but